Alright, so on a problem like this, what we have is we're going to be looking into some what we call special factoring techniques. And for this problem, you can see I have 4k squared minus 28k equals a negative 49. Now, when looking at a problem like this, we've talked about factoring, kind of basic. We talked about factoring by grouping. We talked about factoring when a was greater than 1. And we also talked about factoring with difference in two squares. Now, you could say, first of all, this isn't even solved all the same. Now we have numbers on both sides of the equation. Now, most of the problems that you guys will see, they already are set equal to 0. But now you guys should also be familiar that when we're solving a quadratic, even if this was set equal to f of x, we always need to make sure it's set equal to 0 to solve, right? Remember we talked about the zeros? We said, all right, you need to set your function equal to 0 to solve. Well, this equation, I need to make sure it's equal to 0 before I can solve. So the first thing we're going to do is add 49 on both sides. What that will do, now that will give me an equation that I can solve. And this is very similar to like the homework you guys had last night where you guys were supposed to be doing some type of problems like this, right? Solving, factoring, and so forth, doing some problems. So you guys have 4k squared minus 28k plus 49. Now, you could use the AC method on this, if you guys would like to. That AC method that we talked about. However, ladies and gentlemen, what I do is, what I'm looking at is I'm looking at to see, if I see something large like this, I always want to look, can it be a perfect square? Right? Remember, when we saw two square terms, a squared minus b squared, we know, oh, that's difference in two squares. I can use a special factoring technique, right? Which that would equal a minus b times a plus b, right? Yes, per your homework quiz today. So what is going to be the special factoring technique then? If I have an equation that's in the form of a squared plus 2ab plus b squared, that can be factored into a plus b times a plus b, which can also be factored into a plus b squared, which that's pretty cool, all right? Now, the other thing works is same if it was being negative. It's a little bit different, but it's very close to being the same. So anyways, what I need to do is determine can I write this equation in that format? And what I need to determine, can 4k squared be written as a term squared? Yes, how about this? 2k squared, right? Because what's 2k times 2k? 4k squared. Let's not worry about the 28k right now. And then plus 49, which can be written as 7 squared equals 0. Now, when looking at this, 28, can that be written as 2 times your a times your b? Well, what's 2 times a, which would be 4k, times 7, which would be 28k. Now, I know we're going to be worried about this negative here in a second. But yeah, our middle term is 2 times our a and our b. Right? If that's A and that's B, A equals 2K, B equals 7, then 2 times those two terms is going to make it. Now we can make this negative, so that's okay, and that's what we're going to change, because we need to make our middle term negative. Well, anyways, since this is negative, we know that we need to have our B term can be ahead and be plus and negative, because what's negative 7 times negative 7 is still positive 49, right? So this can be a negative 7 squared. That's okay, because negative 7 times negative 7 is still positive 49. However, it's negative 7 because when we multiply these two and then times the number 2, that's going to give us negative 28k. So therefore, by writing this down, I have negative k minus 7, negative k, 2k minus 7 times 2k minus 7 equals 0, which that's the same thing as 2k minus 7 squared equals 0. Now, there's two different ways you guys can do this. You can write it like this, right? 2k minus 7 times 2k minus 7, that's just 2k minus 7 squared. Or you could also apply, or you can also use the zero product property from here, but you're going to get the exact same answer. So what I'll do is I'll take the square root of both sides. So therefore, I have 2k minus 7 equals 0, and then I solve for k. K equals 7 halves. Now, this has nothing to do with this problem. It's not what I'm asking you, but do you know what would be the multiplicity on that 0?
1, 2,
2.
Oh, yeah.
Because remember, multiplicity, we're always going to go back up to the factor. And notice how the factor has an even multiplicity, so it'd be a multiplicity of 2, meaning that the graph is actually gonna touch at our 0, 7/2. That's not what I was asking you, but I figure I might as well relate it. Anyways, ladies and gentlemen, when looking at the perfect square trinomial, you wanna look for your homework tonight, see if your equation can fit this pattern. If it can, then you can write it in that factored form, okay? Yes?
If it had not been two K's minus 7s, if one of them had been different, would the multiplicity be only 1?
Yes.